A machine that can write essays, generate art, diagnose diseases, and even hold conversations that feel human. Just a few decades ago, this would sound like pure science fiction. But today, it's real. So how did we get here? How did artificial intelligence evolve from simple rule-based programs to systems that can learn, create, and adapt? And more importantly, how far has AI actually come? Because the truth might surprise you, AI is incredibly advanced in some areas, yet still far from human intelligence in others. Before we dive into this fascinating journey, make sure you like this video and subscribe to the channel, because understanding AI today means understanding the future. 1. The early days of AI. Artificial intelligence didn't begin with powerful machines or self-learning systems. It started with very simple, rule-based programs. In the early days, computers could only do exactly what they were told. Programmers had to manually write every instruction, step by step. If you wanted a machine to solve a problem, you had to define every possible scenario and its solution. For example, early AI systems could play basic games like chess, but only by following predefined strategies. They didn't think or adapt, they simply executed instructions. If something unexpected happened, the system would fail unless it had been specifically programmed to handle that situation. This approach showed both the potential and the limitations of AI. On one hand, it proved that machines could simulate logical thinking. On the other hand, it highlighted how rigid and inflexible they were. These early systems lacked the ability to learn or improve over time. Every update required human intervention. But despite these limitations, this phase was crucial. It laid the groundwork for future advancements by introducing key concepts like problem-solving, logic, and automation. Without this foundation, modern AI wouldn't exist. It was the starting point of a journey that would eventually lead to machines capable of learning, adapting, and evolving on their own. 2. The rise of machine learning. The introduction of machine learning marked a turning point in AI development. Instead of programming every rule manually, developers created systems that could learn from data. This allowed machines to improve their performance over time without being explicitly told what to do in every situation. Machine learning works by feeding large amounts of data into an algorithm. The system then identifies patterns within that data and uses those patterns to make predictions or decisions. For example, instead of programming an AI to recognize a cat by listing every possible feature, developers can show it thousands of cat images. Over time, the AI learns what makes a cat a cat. This approach made AI far more flexible and powerful. It could adapt to new information and handle situations it hadn't encountered before. However, this also introduced new challenges. Machine learning systems depend heavily on the quality of data. If the data is biased or incomplete, the AI's learning will reflect those flaws. Despite this, machine learning revolutionized AI. It transformed it from a rigid tool into a dynamic system capable of continuous improvement. 3. The power of big data. As technology advanced, the availability of data exploded. This gave AI systems more information to learn from. Big data became a key driver of AI progress. With access to massive datasets, AI could train faster and achieve higher accuracy. For instance, AI systems can now analyze millions of images, texts, or records in a short time. This allows them to perform tasks that would be impossible for humans at that scale. However, this also created new challenges. Managing and processing such large amounts of data requires significant computing power. Additionally, the quality of data matters. Poor or biased data can lead to flawed results. 4. Deep learning and neural networks. Deep learning took AI to another level. Inspired by the structure of the human brain, neural networks use multiple layers to process information. These systems can handle complex tasks like speech recognition, image analysis, and natural language processing. Deep learning allows AI to find patterns in unstructured data, such as images or audio, which was previously very difficult. This advancement is what powers many modern AI applications, from voice assistants to recommendation systems. However, deep learning models can be difficult to interpret. They often operate as black boxes, making it hard to understand how they arrive at decisions. 5. AI in everyday life today. AI is everywhere. It's integrated into smartphones, social media, online shopping, and more. It helps recommend content, filter spam, optimize routes, and even detect fraud. What's interesting is how invisible it is. Most people don't realize how often they interact with AI. This widespread use shows how far AI has come. It's no longer a specialized technology, it's a part of everyday life. At the same time, this raises questions about dependence and awareness. Many people rely on AI without fully understanding how it works. 6. AI in advanced fields. AI is not just used for convenience, it's making significant impacts in advanced fields. In healthcare, it helps diagnose diseases and analyze medical data. In finance, it detects fraud and manages investments. In science, it accelerates research and discovery. These applications demonstrate AI's ability to handle complex and high-stakes tasks. However, these uses also require high accuracy and reliability. Mistakes can have serious consequences. This makes careful development and testing essential. 7. Creativity and generative AI. One of the most surprising developments in AI is its ability to create. Generative AI can produce text, images, music, and more. This has changed how people think about creativity. AI can generate content quickly and at scale. However, it doesn't create in the same way humans do. It uses patterns from existing data to produce new outputs. This raises questions about originality and authorship. Despite this, generative AI has become a powerful tool for artists, writers, and creators. 8. Limitations of current AI. Despite its progress, AI still has significant limitations. It lacks common sense, struggles with complex reasoning, and cannot fully understand context. AI also depends heavily on data and computing resources. Without them, its capabilities are limited. Another limitation is general intelligence. Current AI systems are designed for specific tasks and cannot perform a wide range of functions like humans. These limitations highlight that AI is still far from human-level intelligence. 9. Ethical challenges. As AI becomes more powerful, ethical concerns become more important. Issues such as privacy, bias, and transparency need to be addressed. AI systems can reflect biases present in their training data. There are also concerns about how AI is used, especially in areas like surveillance or decision-making. Ensuring that AI is developed and used responsibly is a major challenge. This requires collaboration between developers, policymakers, and society. 10. The future of AI. The future of AI involves making systems more flexible, efficient, and capable. Researchers are working toward AI that can adapt to new situations and learn with less data. There is also a focus on improving safety and alignment with human values. The future is not just about making AI more powerful, but making it more trustworthy and beneficial. How far AI will go depends on how it is developed and used. So, how far has AI really come? From simple rule-based systems, to machines that can learn, adapt, and create. It's a journey that has transformed technology, and it's far from over. Because the real question isn't just how far AI has come, it's how far it will go. If you found this video insightful, don't forget to like, comment, and subscribe for more deep dives into AI in the future. And tell me in the comments, do you think AI is advancing too fast, or not fast enough? Until next time, stay curious.